We are given this function as a function of 3 variables, and we're also giving this constraint equation, and we're trying to use Lagrange multiplier to find the extreme value of the function subject to this given constraint. Now, to use the Lagrange multiplier here, so the solution will be like this. We are going to have the gradient of f is going to be a scalar multiple of the gradient of g. Gradient f is equal to lambda times gradient of g. And then we're going to use this. So this is the lambda here is the Lagrange multiplier. And then we use this equation together with this constraint equation. So using this equation, this constraint equation, we should solve for x, y, z, and then we can substitute those x, y, z into the function, and then we can compare and find the extreme value, okay? So that's the idea. This equation over here actually can break down into several equations here, break down into 3 equations because it has 3 components, x, y, z. So from this one over here, what's the gradient of f? So gradient of f will be, the first component will be the partial derivative of f with respect to x. What's the partial derivative of this function with respect to x? What do we have here? Take the derivative of that with respect to x, e to the x, y, z, and then multiply by y, z, right?
Okay. Yes.
Okay, and then the second component, the partial derivative this with respect to y is very similar. So e to the xyz times xz. And then the partial derivative this with respect to z will be similar, e to the xyz times xy. So this is gradient of f. So we just take partial derivative of e with respect to x, with respect to y, with respect to z. And then over here on this side, we have lambda. So we'll have lambda times, now let's take the gradient. What's the gradient of g? For x, right?
Mm-hmm. Yes. Plus 2y or comma 2y.
Yeah, so we have 4x. Okay. The partial derivative this with respect to x is 4x. And then the second one will be 2y. And then this one will be 2z. Right? Did I make a mistake? Oh,
no,
not yet. Not yet. Okay. Now that actually break into 3 equations. So we have this equal to the first component equal. So we have yz e to the xyz is equal to lambda times 4x. And then we have xz e to the xyz is equal to lambda times 2y. And then we have xy e to the xyz is equal to lambda times 2z. Okay, how do we solve it? That's the question. So we have this, and then we're going to solve. So what are we doing? We're trying to solve the equation together with this equation and solve for xyz. Okay, let's see how do we solve it. Let's take a eye. Now what happened here is, take a look here. So you have this and this, and this and this and this. Okay, one of the simple thing here is to think about what happened here if either x, y, or z or lambda equal to 0, if this side equal to 0, right? Suppose this side of the equation equal to 0, then we have a much simple equation to solve, right? So let's say what happens if this side equal to 0? If one of this, okay? If one of this is equal to 0, then it's easy to solve, okay? So let me write that down. So if one of x, y, z, or lambda is equal to 0. Okay, for example, let's think about if x is equal to 0. If x equal to 0 over here, then you have 0 on this side. Then this side, that will be equal to 0. For this equal to 0, either y equal to 0 or z equal to 0 or this equal to 0. But e to this is never going to be 0 because the base is e. So it's never 0. Okay, so this one here never 0. So suppose x equals 0. Then we have y times z equal to 0, which means that either y equal to 0 or z equal to 0. Okay, so let me write down. Say x equal to 0, then we'll have y equal to 0 or z equal to 0. From, let's call this equation 1. From equation 1 right there. Okay, this is A. Okay, let's think about what happens if y equal to 0. If y equal to 0, then you have 0 over here. Similar reasoning if as either x equals 0 or z equals 0. Okay, from 2. So then x equal to 0 or z equal to 0. Okay, this is from 2. Okay, and then this one over here, what happens if z equal to 0? Then x equal to 0 or y equal to 0. And this is from 3. So what does it mean? So if x equal to 0, then the other two, one of them has to be 0, right? Do you agree?
Yes. Yes.
Okay. Okay. So we have this possibility, right? So you have x, y, and z. So if one of them equals 0, then you will have two of them equal to 0. So now what about if all of them equal 0? Okay. Well, can all of them equal 0?
No, because the constraint has equal to 24.
Yeah, this one here is going to contradict this equation, right? Yeah, so that is not going to happen. So let's call this equation number 4. So this is not possible. So then this contradicts the equation number 4. So you cannot have all of them equal 0. So that is not going to happen. So we will have exactly 2 equal to 0. Okay, exactly 2 are 0. So either x, y equals 0, y, z, or that. So for x, y, z, you will have exactly 2 equal to 0. Okay.
Okay.
If one of them equals 0, you will have exactly 2 equal to 0 out of this x, y, z, but not all of them.
Okay.
All right. So now we have exactly 2 equal to 0, right? So look at this equation 4. So if we have x and y equal to 0, x and y equal to 0, then what does z equal to?
The square root of 24.
Yeah, let me write that over here. This one, equation 4 is 2x squared plus y squared plus z squared equal to 24. So if x equal to y equal to 0, then z is plus or minus square root of 24, right?
Yes.
Okay. So the xyz here will be equal to this 0, 0 plus or minus. This is plus or minus 2 square root of 6. So 2 square root of 6. So we have this. So you can have xyz. So this will be one solution. Actually, two solutions right here.
Okay.
Now let's try the other two equals 0. So what happens if let's say x equal to z equal to 0? Then what do we have? Substitute into this.
It would be the same thing as.
Yeah, it's the same thing. So y is plus or minus 2 square root of 6, right? So the xyz here will be 0 for x, 0 for z, but then plus or minus 2 square root of 6 for the y, right?
Yes.
Okay, now let's try another one. So how about y equal to z equal to 0? Then x squared is equal to 12. So x is plus or minus 2 square root of 3, right?
Yes.
Okay. So xyz is going to be plus or minus 2 square root of 3 and then 0, 0. So we found this, right?
Yes.
Okay. All right. So if you substitute all this into the function, if you substitute those xyz into this function, what function value do you gonna get?
It'll be e to the, oh no, it'll be 1.
Yes, you got it. So if you substitute all of this xyz into this, all function value, okay, of all those xyz, if you have those xyz here or here, and that will be equal to e to the 0, right?
Yes.
And which is equal to 1. So all of those have function value to be 1. So we covered the case that if one of xyz or lambda is equal to 0. That was the first case, right?
Mm-hmm.
So we have this one over here. Okay, so this is this case. This is first case right here. Then we found those x, y, z over here, and you get the function value will be 1. Okay, let's think about another case over here. The case 2. If none of the x, y, z is equal to 0, okay, none of them equal to 0. We just have that if one of them equal to 0, right? So the rest will be if none of them equal to 0. But none of the x, y, z and lambda equal to 0, okay? And also lambda is 0. Okay, then what happened? Okay, let's look at the first 3 equation over here. So none of them equal to 0. We have an equation that is a little bit more complicated to solve. Okay. All right. None of them equal to 0. Do you observe there's a pattern in all this equation? They all have e to the xyz, right?
Yes.
How about we try to express e to the xyz?
Oh, okay. And set them equal?
Yeah, and then set them equal. Okay. So then this is going to be equal to 4 lambda x, and then divide by yz, okay? And then this one here is 2 lambda y, divide by xz, and then this one here will be 2 lambda z, divide by xy. And then they're all equal, right? So now we have all this are equal, so they're equal. So setting the equal, notice that this is 4, this is 2, this 2. If you divide each one of them by 2, we're going to have 2 lambda x over yz equal to lambda y over xz equal to lambda z over xy. Okay?
Okay.
You agree that?
Yes.
Yes. So how do we solve this? Well, we can try. Well, we can also get rid of the lambda, isn't it? Divide all of this by lambda because lambda is not 0. So we can actually divide by lambda.
Okay.
So we can get that one out. So let's get that out. The lambda divide out. That looks a little bit simpler. Okay. And then you can do, what can we do? We can do cross multiply, right?
Okay.
So 2x times this. Okay, so we can cross multiply.
Okay.
So we can have this times that equal this times that. So we will have 2x squared z equal to y squared z.
Okay.
Actually, the z can also get
And
out.
you can cancel out the z.
Yeah, so then you will have 2x squared equal to y squared. Now that's for this one. And then for the other one, you can also do cross multiply. Then that will give you xy squared equal to x z squared, which is going to give you what?
X equals, you cancel the x, cancel out the z.
Yes, y squared equals z squared, right? Okay, good.
Yes.
You get this? All right. Oh, over here, you can actually substitute y squared equals z squared. You have y squared is 2x squared and z squared equal to y squared. So what was the fourth equation that we have? So we have this one over here. So these two equations actually enable us to express y and z in terms of x. Y squared, z squared can be expressed in terms of x squared, right? We can actually, in this equation, we can replace the y squared here by what? So the y squared by 2x squared, and then z squared also be replaced by what?
2x squared.
X squared, yeah, that's good. So that will enable us to solve for x. So we have 6x squared on this side. 6x squared equal 24. So x squared equal to 4. X equal to what? Plus or minus?
Plus or minus
2, right?
Yep.
All right. So if x equal plus or minus 2, we can also, so because y squared is 2x squared, so we will have y squared is what? So y squared is 2x squared. So it will be 2 times 4, which is 8, right? So that means y is plus or minus 2 squared to 2. And also for z, right? And z is also plus or minus 2 squared to 2. Okay, so that will give us the xyz. So xyz here will be, this will be plus or minus 2 for x, plus or minus 2 squared to 2 for y, plus or minus 2 squared to 2 for z, okay? And you should have 2 times 2 times 2. You should have 8 combination. So this should be 8 combination, right? 2, this. So it's all combination.
8 different combinations.
Yeah, 2 times 2 times 2. So 8 combination. Okay, so now we can substitute this xyz into the function. So the function we have is this one. It's this one right there. Let's substitute into xyz. Okay.
Okay.
Let's try it. Okay. All right.
We have to do all 8 combinations?
I wonder. So that's equal to E. Let's just try and see a pattern, okay?
Okay.
So how about we take positive.
All the
Okay,
positive.
let's take all positive first. So what do we have? So you have 2 times, this one here is 2
16.
times root 2, and then 2 times root 2. So is e to the
16.
16? Yeah, 16. Okay, so it's e to the 16, positive, okay?
Okay.
So, and then what else you can get? So you can get e to the 2, and then you have a negative here. And then you have, well, okay. So think about there's only 2 possibilities. So either the sign here will be, let's think about how many negative signs, what will be, if we multiply them, what number can you get? If all positive, then it's positive, right? But if it's all negative, you will get negative 16, right?
Yes.
Okay, so suppose you get all negative, okay? Then you will be e to the negative 16. Can you get other possibility?
Oh,
Well,
no, because both will be positive. If you have
yeah.
negatives and one positive, it's still positive.
Yeah, that's why this is the only 2 possible
Okay.
result, because the negative sign will cancel. So e to the 16 or e to the negative 16 are the 2 possible function value at those xyz.
Okay.
Now we found those, right? So there are only 2 cases. One of the case is if one of the xyz or lambda is 0. The other case is if none of them is equal 0. We cover all the cases. And then for this case, the first case, we come up with those xyz, and we found the function value is 1. For the second case here, we found the function value will be e to the 16, e to the negative 16. Then now we can just compare them, right? So we can compare and see which one is the max, right?
Yes.
So we have this, and then we also have this one. So obviously the max will be, what's the max?
E to the 16.
Yeah, it's e to 16. And what's the mean?
E to the negative 16.
Yeah, e to negative 16. That's less than 1. Yeah. So that's the, yeah. So you found that after all this work, this problem over here is actually a little bit tricky because you have to consider 2 cases. One of the case is when one of the x, y, z or lambda is 0. The other case is when none of them is equal to 0. I think there might be other way to do it, but I think this is maybe one of the easier way to do it.